Hello and welcome to my presentation on the twin paradox. First, let me explain time dilation. It can be summarized by saying moving clocks run slower, or that time in a moving frame is slow relative to that of an inertial observer at rest, especially at near light speed. This concept is key towards the twin paradox. The premise of the thought experiment is that there are two identical twins, A and B. Twin A stays on Earth while twin B travels to a star 8 light years away at 0.8 times the speed of light. After they've reached the star, they then return to Earth. My initial assumptions are the following. The Earth is an inertial system despite rotating and orbiting. Both twins have very precise clocks that start takeoff and track their personal times until twin B finally returns. The turnaround time is negligible as this rocket turns around at the star. The spaceship travels in a straight line for the entire journey except to turn around. The relative velocity between the twins' reference frames is constant, so that each reference frame for twin A and twin B is inertial. The paradox arises from the fact that each twin observes the other moving away. So twin A thinks that twin B is moving away on the rocket ship, and twin B thinks twin A is moving away on the Earth. So each twin thinks the other is experiencing time dilation. This raises the question, who is older? And furthermore, if both experience time dilation, are they the same age when B gets back to Earth? The solution to this supposed paradox is that the system is not symmetric. Twin B must accelerate and de-accelerate in order to turn around and head back to Earth when they reach the star. So that means they end their current inertial system and transfer over to a new one. On the other hand, twin A does not have to accelerate at all on Earth, so they remain at rest and hold a constant inertial system. This means that twin B is the one that experiences time dilation, so when they eventually go back to Earth, they will be the one that is younger than twin A. In this visualization, twin A is at rest on Earth in the K frame, where a clock measures the time period TA, and the ship is traveling at a speed 0.8 times the speed of light. In the system K prime, twin B is at rest on the ship and a clock measures the time period TB. The distance between Earth and the star is 8 light years. We can find exactly how long the trip took for each twin and the difference between these times using these key equations. The basic time equation, time equals distance over velocity, or d over v, and the time dilation equation, where t0 is the time period of the rest frame, or the proper time, and t is the time period of the moving frame. Proper time equals t times the square root of 1 minus velocity squared over c squared, or the speed of light squared. To find how long each trip took, we begin by finding the distance traveled by the rocket ship. This is 2 times 8 light years, producing 16 light years. The time measured by twin A, TA, is equal to the distance divided by the velocity of the rocket ship, so 16 years divided by 0.8 equals 20 years. Since light year divided by the speed of light just reduces to regular years. The time measured by twin B, TB, is found using the time dilation equation, where TB is the proper time in the rest frame and TA is the time period in the moving frame relative to twin B. So 20 years times the square root of 1, 0.8 squared c squared divided by c squared reduces to 20 years times 0.6, which equals 12 years. So how much older is twin A? According to twin A, the trip took 20 years, while for twin B, it took 12. 20 minus 12 is 8, so twin A is 8 years older than twin B when they finally reunite. Here is a space-time diagram describing the trip. We shall let B take off from Earth at the origin, and their path is described by these two world lines. The outward world line has a positive slope as they travel to the star 8 light years away from Earth, but at the star they then turn around and return back towards the Earth. This world line has a negative slope as it's returning back towards x equals 0, but at a much later time. Twin A's world line, on the other hand, is simply a straight line as they do not travel from their position on Earth. Thank you for listening to my presentation, and I hope you have a nice day.